Okay, I had given you a lot of examples about oxidation number. You have to go back and practice them. Here, like and therefore, for oxidation numbers can be used to identify the elements that are oxidized and the elements that are reduced in a reaction. How? When the oxidation number for an element increases, it means oxidation, it had been lost electrons, has occurred. Fe to Fe plus 2. The oxidation number, it had been increased. من Fe0 to Fe plus 2. What does it mean? It means already it has lost electrons, but the oxidation number, it had been increased. And there is an oxidation that had taken place. Whereas if I have Cu plus 2, it had turned to Cu0. It means there is a decrease in oxidation number. Means Cu plus 2 to Cu0, it had reduced, decrease in oxidation number, and here it had been gained electrons, reduced. Here I have another example. Fe plus 3Cl2, it gives me FeCl3. Fe0 to Fe plus 3, an oxidation had taken place. Fe0 to Fe plus 3. It had been here oxidation, loss of electrons. The oxidation number increased. Okay? Whereas here, Cl2, it had been 0. Now Cl is minus 1. Cl, it had been 0. Cl now is minus 1. Decrease in the oxidation number. And here it had been reduced, the Cl. Okay, here I do have an arrow. Reduction, it means oxidation number decreases. And oxidation, it means oxidation number increases. I have here an example for you. Identify the element that is oxidized and the element that is reduced in the following equation. Carbon dioxide plus hydrogen gas, it gives me carbon monoxide plus water. Okay, here I have, in this case, assigned the oxidation numbers to each element first. Here I am using rule 1 and rule 2. Oxygen is minus 2. Oxygen, I have 2 atoms of oxygen, therefore it will be minus 4. A carbon plus 4. Hydrogen, it is 0 as a diatomic. Carbon monoxide, oxygen minus 2, but therefore carbon is plus 2. H2O, oxygen is minus 2. Hydrogen is plus 1 times 2, it will be plus 2 as 2 atoms of hydrogen. Here in this case, for therefore I am going to identify which one it had been increased in oxidation number. Whenever it had been increased in oxidation number, we will consider it as it had been oxidized. The one that it had decreased, it will be the one that it had been reduced. Okay. Carbon dioxide here, carbon, in which it had been before plus 4, now I have the carbon plus 2 oxidation number. Here there is a decrease in oxidation number. What does it mean? It had been undergone a reduction. Whereas hydrogen here, 0, it had turned into H+. Therefore, here there is an increase in oxidation number. But therefore, this is oxidation number. It had been increased. There is oxidation. Always you have to put in your mind, like if the oxidation number, it had been increased, therefore this element it had gone what? Already oxidation. Oxidation number had increased from Fe0 to Fe plus 2. Oxidation number, it had been increased. Therefore, oxidation. And it had lost electrons, whereas reduction is the reverse. Now I'm going to talk about another concept about reducing agent and oxidizing agent. In an oxidation reduction reaction, the substance that is oxidized is called the reducing agent because it provides the electrons. The substance that is reduced is called the oxidizing agent because it accepts the electron. What does it mean? Here I have Zn solid plus copper sulfate. I've got copper solid plus ZnSO4. First of all, I have to check which one it had been oxidized and which one it had been reduced. I have Zn solid. It had lost 2 electrons, and I've got Zn plus 2. Zn plus 2 SO4 minus 2. Therefore, Zn solid, it had lost 2 electrons. I've got here Zn plus 2. Therefore, Zn had been oxidized. Okay, lost electrons. Here I have copper plus 2. It had gained these 2 electrons, and I've got copper in the form of solid, Cu solid. Therefore, it had gained these 2 electrons, it had reduced, and I've got copper in the form of a solid. Now we ask ourselves, which one in here, in this equation, or in this reaction, had helped Zn in order to be oxidized? Zn had been oxidized, but the one that helped Zn to be oxidized is copper plus 2. Because copper, it's the one that's already, it had gained the electrons from Zn. And because of this, copper, I just say that copper plus 2 is the oxidizing agent. It helps Zn to be oxidized. Copper plus 2 is the oxidizing agent. It had accepted the electrons and it had gained them. And the reverse is true for what? For copper. Copper, because already it had been now reduced, which one it helped copper to be reduced? The one that helped copper to be reduced is Zn. Zn solid is the reducing agent. It helped copper to be reduced because already it provides these electrons to the copper. Therefore, what do we say? The substance that is reduced is called the oxidizing agent because it accepts the electrons. And the one that it is called the reducing agent, it is the one that it provides the electrons. Okay. What about here, for this case, Zn plus 2H plus 2Cl minus, I've got ZnCl2 plus hydrogen. Zn also, it had been oxidized, and H plus, it had been reduced to H2. Zn had been oxidized to Zn plus 2. Therefore, Zn is the reducing agent, and H plus is the oxidizing agent. Here I have another equation, lead oxide plus carbon monoxide. It gives me lead plus carbon dioxide. Okay, here I have to check the charge first. Pb is plus 2, oxygen is minus 2, carbon monoxide is plus 2, oxygen is minus 2. I've got lead product 0, carbon dioxide, oxygen is minus 2 times 2 is minus 4, therefore minus 4, carbon is plus 4. Therefore here I have to check which one it had been reduced and which one it had been oxidized. Okay? Here in this case, the one that it had been oxidized is carbon. it had its charge, it had been before +2 to +4. There is an increase in oxidation number from +2 to +4. It had been oxidized, increase in oxidation number. So therefore, this is the one that is called the reducing agent. As for lead, this is the one that it had been reduced. Why? Because +2 as a charge, it had turned into lead 0. There is a decrease in oxidation number, and therefore it had been reduced. It had gained the electrons, and we call lead the oxidizing agent. Thank you so much. I had some examples for you. I would like you to go back to in order to understand very well the concept. Thank you so much.